All right, so this whole lesson is going to be about completing the square. And to start that, we have to understand what a perfect trinomial is. I say perfect trinomial. By definition, it's a trinomial that can be written as a binomial squared. So again, it's a trinomial that can be written as a binomial squared. So basically what I mean is this. If I gave you x squared plus 6x plus 9, that's a perfect trinomial. Why? If you factor that, you factor it and you'd be looking for, you have x here and x there. You look for numbers multiply together to be 9 and add to be 6. Well, that would be 3 and 3. And both of those have plus signs. So it's essentially x plus 3 quantity squared. That's the reason why this is a perfect trinomial. So a perfect trinomial is any trinomial that can be written as some binomial squared. Another example of a perfect trinomial is x squared subtract 12x plus 36. If you factor that, you get two binomials, and they'd be x subtract 6 times x subtract 6, or even better, x subtract 6 squared, making it a perfect trinomial. You may notice that this number always gets split in half here. So basically, if I gave you a perfect trinomial, it's always going to be written as x plus or minus whatever b divided by 2 squared. So whatever the b value was, you can always take half of it and then square it. Or in this case, if it could be subtraction though. If it's subtraction here, it'd be subtraction there. If it's addition here, it'd be addition there. But anyways, always the b value divided by 2 squared. So if you actually want to find out, that's how it's always going to factor to be. Just know that. So the question is x squared plus 8x plus 16 a perfect trinomial? Well, if it was, it should factor be x plus b divided by 2 squared. So in this case, b is 8. So it should be x plus 8 divided by 2 squared. Oh, if you don't remember why b is 8, remember a is the coefficient of x squared, b is the coefficient of x, c is a constant there on the end, from the standard form of a polynomial, of a quadratic. So anyway, what we have is x plus 8 over 2, which reduces to be x plus 4 squared. So that means that if it was a perfect trinomial, it should be factored to be x plus 4 squared. So if you factor this, x squared plus 8x plus 16. Use the x game, or if you're really good with it, you can go straight into the 2 set of parentheses. And you're looking for what multiplies together to be 16, add to be 8. Have to have like signs, and both are positive. What multiplies together to be 16, add to be 8? Well, 4 and 4. Give you x plus 4 squared. Same thing. So they do match. So the answer is yes. It is a perfect trinomial because it does factor to be x plus b over 2 squared. So that's how we can recognize it, and that's how we can factor them really quickly. If we recognize the perfect trinomial, I can go straight to what the factors are. I know exactly what they're going to wind up being. All right, another example. All right, and this example says find the value of c so that the expression is a perfect trinomial. So you want to find out how to make this thing a perfect trinomial. And as of right now, it says x squared plus 10x plus c. Basically, c is always going to wind up being half of b squared. How it has to work. So you know what half of b is, you simply square it. So in this case, b is 10. So that's the case, it's going to have to be 10 divided by 2 squared, which is 5 over 2, 5 squared, which is 25. So that means the polynomial should be x squared plus 10x plus 25, and that's a perfect trinomial. Look, the next one is not an easy number to take half of. It's a fraction. That's okay. C is still going to wind up being half of b. B is negative 11. You're going to square that. And you can call that negative 5.5, because that's what half of negative 11 is. Or we're going to square this. And we square it means to square the numerator and square the denominator. Make it positive 121 over 4. So it means c has to equal to positive 121 over 4. So this is going to be x squared, subtract 11x, plus 121 over 4. where C has equal to this piece. And the last one, a little bit easier to look at, you probably can look at this tail right now. We take half of C, so we take half of negative 22 and square it. So it's going to, half of B and square it. So you get negative 11 squared, which is positive 121. So C has to be 121. So the expression is x squared, subtract 22x plus 121. And now all those are perfect trinomials. All those are really easy to factor and so forth. Like you can see this factors to B, x plus 5, quantity squared. This would factor to B, x plus half of B, or better yet, x subtract half of B squared. And it's going to wind up being x subtract half of B squared. So I can factor those really easily and put them in a squared form, which is useful if we actually want to solve the equation by taking the square root. All right, moving forward. All right, this is up to solve the equation for x. And up until now, we could solve it by factoring. However, you can't factor this. You can't find two numbers multiplied by 2 and add to be 8. So if you use the x game, whatever method you use to factor, you realize you can't factor that. So if that's the case, we have to find other ways to find the solutions to it. So we could graph it, find a solution to it. But before we start depending on the graph for everything, let's actually see if we could find an algebraically a different way. We could actually change the format of it using completing the square and solve it that way. What I mean is this: if I isolate the variables and get all the variables on one side and all the numbers on the other side, I begin by adding 2 to both sides. Leaving with x squared, subtract 8x equals 2. Now, what I want to do is create a perfect trinomial. So from here, I'm going to take this x squared, subtract 8x. I'm going to find out what the c value is. And whatever that c value is, I'll add it on both sides. That way my equation is balanced. If I add a c here and add a c there, it's still the same equation. Prime example, if I subtract c, the c's cancel here, c's cancel there, leave you just this piece, which is what I began with, equals a 2, which is what I began with. So as long as I add c to both sides, I'm okay. So if that's the case, I really want to find out what c is. So how are we going to find c? Take half b and square it. So it's going to be negative 8 divided by 2. I'm going to square it. And on the right side, you can have the same thing. Negative 8 divided by 2 squared. So this now gives you x squared, subtract 8x, plus negative 4 squared equals a 2 plus negative 4 squared, which gives you x squared, subtract 8x, plus 16 equals a 2 plus 16. Now you probably know how to factor this using the x game, or you can go straight into what the factors are. If you looked at that using the x game, you would figure out that this has to be x subtract 4 times x subtract 4, and that's equal to 18. All right, well from there, what I know is x subtract 4 times x subtract 4 is really x subtract 4 quantity squared. And that's equal to 18. So now we've learned in the previous lesson that if I want to solve this equation, I can simply square root both sides. So I can square root the left side, square root the right side. That gives you x subtract 4 equals the positive negative square root of 18, which if you know square root of 18, that's really x subtract 4 equals the positive negative square root of 9 times 2. So it's x subtract 4 equals a positive negative 3 square root of 2. And if you want to get x alone, you add the 4 to the other side. Give you your final answer. Final answer is x equals to positive 4 plus or minus 3 square root 2. And that's it. That would be the solution to it. So if we actually want to check that solution out, we can graph it to figure out if it works, or we can plug into the calculator, figure out what this is as a decimal, and evaluate that decimal value back into the calculator for x, into the equation for x. Either way works, but that's how you find it. It looks like there's a lot happening here. but you can eventually get really fast with it, whatever. So that's how you could solve an equation using completing the square. Give you another example before I say I feel like I told you this pretty well. But you definitely want to write this down as a note, make one big note with all this stuff in it, and I'm going to give you more. All right, write down this example, solve the equation for x, and this is the equation. 2x squared, subtract 24x, subtract 28. If I was doing this, the first thing I would do is find the GCF. GCF here is 2, so we factor out of 2. So after I factor out of 2, I get this equation. I really don't need this 2 anymore. If I want to solve this equation, I want to get rid of it so I can divide both sides by the 2. So rewrite this equation. I'm going to divide the left side by 2, divide the right side by 2. So these 2's go away. 0 divided by 2 is 0. So you only have x squared, subtract 12x, subtract 14. And then you'll see if you can factor that. You might notice you can't actually factor this. It's not factorable at all. So if that's the case, you want to actually try to see if you can actually use completing the square. So your next step would be to isolate the variables. So I'm going to take this 14, add to the other side, leaving you with x squared, subtract 12x, equals a positive 14. And then your next step would be create a perfect trinomial. So it's going to now be x squared, subtract 12x. You got to take half of b squared. I'm just going to do it in my head. Negative 12 divided by 2 is negative 6. You square that, it's 36. So it's going to be 14. You have to add that 36 over here as well. All right, so we're running out of space. Let's move over here. What we now have is a perfect trinomial, which factors. You should recognize that factor to be x subtract 6 times x subtract 6. So the factors would be x subtract 6 squared equals to 50. Not really sure why, just you gotta look at previous notes to learn how to factor. 14 plus 36 should be 50. So from there I can square root the left side, square root the right side, giving me x subtract 6 equals to positive negative square root of 50. At some point we should recognize square root of 50 is really going to wind up being plus or minus 5 square root of 2. This is x subtract 6 on the left side. So our solution is x subtract 6 equals this. I can add 6 to both sides, give me x equals to 6 plus or minus the square root of 5 square root of 2. Plus minus 5 square root of 2. And this would be our solution for it. X has to be 6 plus or minus 5 square root of 2. And that's the exact answer. You can check it if you want. And let's talk about one more use for this. All right, so other than solving equations, the last usefulness for knowing how to complete the square is be able to write the quadratic equation in vertex form. So this is a quadratic equation, and we talk about vertex form, which is y equals to, vertex form is this. Y equals a times x subtract h squared plus k. If you notice, you got a binomial squared there, which is what the completing the square method is all about. So basically, what you want to do is figure out the value of c. So I'm going to rewrite this. X squared plus 4x plus c. And this subtract 9, put it on the end. I'm going to subtract c from it. So if I have a plus c here and subtract c there, they both add to be 0 c's, so it's okay. So I'm going to group this together so that they are alone. X squared plus 4x plus c. And then it's going to be subtract 9, subtract c. So I want to figure out what c is. It's half of b squared, so it's going to be y equals to x squared plus 4x plus half of b squared. And whatever that c is, you got to add another end, half of b squared there. Well, that should be y equals x squared plus 4x plus 4, subtract 9, subtract 4. This is a perfect trinomial, so it factors to be x plus 2 squared, subtract 13. So now it's actually in vertex form. I can see my vertex. I know my vertex has to be negative 2, negative 13. I can clearly see that by looking at the equation. And this is, again, you should recognize that factor to be x plus 2 squared. But anyways, that's it. That's how it's useful. I want to give you another example, but I'll give it to you in class tomorrow. Good luck. That's all I have.